Hi guys, welcome to Jessilver's Solution to Past Question Challenge. The last time we talked about past questions, WAEC past questions on physics, we talked about the year 1988 and we solved objective problems from 1 to 3. Right now we want to see how we could solve objective problems from 4 to 6. Alright, so we have the three coplanar, when three coplanar and non-parallel forces are in equilibrium. One, they can be represented in magnitude and direction by the three sides of the triangle taken in order. That is actually true. And we call this particular statement, we call it the triangle law under equilibrium of forces. Triangle law. Alright. So if we had under the coplanes on the same planes, alright, where we could recognize the XY axis, when this is properly taken into cognizance, it can be converted to the three sides of a triangle using both cosine and sine rule. So it actually works. Let's say here happens to be f1, f2, f3. With proper taking in order, we can actually relate them to the three sides of a triangle. That's what it means to be in equilibrium. All right, so the first statement checks out, the second statement checks out. Also, they said the magnitude of any one equals the magnitude of the resultant of the other two. In other words, when let's say F2 and F3 are combined based on their angles, it would have to equal the effect of F1 alone because it is in equilibrium. That is a concept here. Being in equilibrium has that. All right. So number three statement, it happens to be true. They said also any one force is the equilibrant. In other words, it balances the system. One force balances the system for the other two. This also checks out. All right. So which means option D happens to be correct. All right. Haven't answered that. The next one we would like to solve would be the number 5, a ball of mass. In order to solve this problem, I think you might want to know about momentum. All right. So a ball of mass 0.5 kg moving at 10 meters per second collides with another ball of equal mass at rest. In other words, the second ball doesn't really, in as much as it's of equal mass, doesn't really have velocity, is at rest, zero velocity. If the ball moves off together after the impact, calculate their common velocity. I think here momentum is conserved. Momentum has to be conserved for us to really finalize what the final or common velocity would look like. But before that, I would like to use a diagram to illustrate the situation or scenario here. So a ball of 0.5 kg moves towards this direction at 10 meters per second. All right, onto a ball at rest, which happens to be the same 0.5 kg, but with zero velocity. I think the outcome here would mean two balls which are headed towards the same direction, having a common velocity, which we are going to call V, and we call this body A, and we call this body B. So these two masses remains the same since matter can neither be created nor destroyed. Matter is conserved too. So taking that to cognizance, I could tell you that the formula for this will be given by this was the only body having momentum. This had zero momentum. So we have here m subscript a, mass of the body, times velocity of the body. All right. So please, you also have to understand that momentum, the formula for momentum is given by mass times velocity. All right. So that being said, we have here would have to equal mass because it would have to carry the mass of the first and second body plus mass of the second body all multiplied by the common velocity. All right. That take into cognizance. Let's go into the next board. That take into cognizance, we have here 0.5 kg, which happens to be mass of A, times 10 meter per second, which happens to the velocity of A, is equal to 0.5 plus 0.5, all multiplied by the common velocity. So here would give you 5 equals 1 v, which dividing through by 1, actually, since it's the coefficient of v, we still have v with 5 meter per second. Alright, so velocity, common velocity here happens to be 5 meters per second. Alright, the options here might not clearly have u with 5 meters per second, but you have to also know that 5.0 is the same thing as 5. Alright, so C happens to be our answer. So the next one we want to talk about is the number 6 question, which if you would want to understand more about would be about projectile in physics. You would have to study about projectile. So a body of a body is projected into space with an initial velocity of v subscript o. All right. So what this actually, or what they were trying to say here is v of this at an angle theta to the horizontal. Which of the following statements are or is correct about its motion? All right. So we have here the total time of flight is given by, all right, proper representation of this should be v subscript o cos theta all over g, of which I think is still not the case here. And then this also entails v subscript o sine square theta all over 2g. All right, while this also tries to say v o raised to the power of 2 cos square theta all over g. Before I actually explain how all of this is wrong, I may not explain it in this video, but if you want to know more, probably you have to follow me. I would want to give an illustration using a diagram. So, given a particular plane, we have a projectile that has this trajectory. Oh, take it easy. Trajectory, making an angle theta. The maximum height would be attained halfway of the trajectory, and then the initial velocity has to be from the start point. There are things you have to take to cognizance here. We have height, maximum height, horizontal distance traveled, which happens to be the range, and also the time of flight. All of which in physics for an inclined projection for total time of flight, it is given by 2u sine theta all over g. Alright? Of which that is not what we have seen in the options here. And then for maximum height is given as alright, h is given as u square sine square theta all over 2g. Probably if you want to understand this the more, you might want to follow me. I might be doing a full explainer course on this topic. Alright, so we have this, which also isn't the case for the options provided in the statement. And also we have the time of flight. Sorry, the time of flight have been discussed. Range, of which the range is given by u square sine 2 theta over g, which happens to be acceleration due to gravity. So, but then since the options, none of the statements are correct, and the options are still given, and none of them says none of the above, I think taking any options here pretty much would equal the same score. Alright, guys, it's been wonderful. If you want to see more of these videos, you would want to or would like to follow me, I expect to see you, and that would be very soon. Have fun and take care. Bye.